Hi guys, and welcome to our new Tyflow tutorial. This was inspired by this beautiful rendering by Sartak Pandey. He published this. I hope I'm not mispronouncing your name, Sartak. He published this animation on the Tyflow group. It's simple but beautiful, and I just wanted to replicate it. And a few people asked for a tutorial, even if the basics of it are quite simple, in my opinion. So here's the tutorial. So that's how my version of it. And there it is. I think the principle is similar. It changes a bit in the speed of animation, but the principle is, I think it's the same. So let's do it from scratch. Let's start with our taurus. We create it, we center it, and then let's increase the subdivisions. Okay, maybe, yeah, more like this. Okay, let's add an edit poly modifier, and in the ribbon tools we can see there is a generate topology panel. We just select one edge and click on the hive, and there it is. Geometry is already in there. So let's create a Tyflow. What we can do is birth objects. We pick our taurus, and then we immediately do a face fracture. And the max, we work on polygons, and the max face per fracture to 1. So everything is, each face is a particle. Let's see how this is working. We can just use a push just for testing. And we pick the same torus as a surface to be pushed away from. And yes, as we can see, each face is a particle. And we can hide the original torus, and we'll add some a shell to give it some thickness. Let's set it to 1, for example. Yeah, even 0.5 maybe. 0.5, yep. Let's hide the grid. So what's the principle behind the animation? Let's watch the animation once more. What's happening here? The main thing is the particles are going away, and then they're going back to their start position. This is the main thing in this animation. The rest of the bells and whistles is quite easy. For example, the cage geometry is just the same object duplicated, and we can do it in an instant. But the main thing you should focus is, okay, the particles are in one place, they go out. It looks like they go out along their normals. So this is one thing we should set as well. But then after a few time, they go back to their original position. So how do we do that? Let's focus on this first, so because it's the core of this animation, and then we'll see everything else. So we can see that we're pushing out the particles along the normals of the original object. I'm gonna disable shell for now, just for speed. And what we're gonna do is use the custom properties. So we're gonna rename this in original set. Okay, and what we're gonna save here is I'm gonna save the transformation matrix. You could save the position and rotation as well, but if you wanted to scale them over time, then you should use transformation matrix. And my TM is gonna be the float channel where we're gonna save it. So what I'm doing here, I'm just saving in each particle position, rotation, and scale in this custom float. Then let's do the simplest version of it. Let's do a time test. After 10 frames plus or minus 5, we push the particles out. As you can see, after 5 frames or after 10 frames plus or minus 5, the particles go in the next event and they're pushed out. We can see also the color. I set a different color for the display. And then let's do the same. After a few times, they go in this other event. And in this other event, what I want to do is take them back to their original position. This is quite easy because we just turn this operator to get. There it is. So this is the core of this effect. What we can do here is notice that if we set this is true for so many operators, but let's see it for this one for now. If we set the timing on continuous, and if we turn the interpolation down, for example, to .1, going back to their original position, to their original transform, is gonna happen in an animated, smooth way. Okay? Maybe it's even too much, maybe 0.3 interpolation. So this is the core of the whole animation. It is quite simple. Let's add all the remaining things. For example, the cage effect. What we could do here is this: we could duplicate the taurus. Let's hide the Tyflow for now. We duplicate it twice. Select all the polygons and inset them by polygon. .3, for example. Okay. And yeah, we don't need the double torus. We can just detach those to hexagons, and then just add a shell to this one. Okay, so this is the cage, and what we can do here is just, well, you can do whatever you want. I mean, you can add a chamfer, for example, amount .1. Do I have to select the edges before? I don't know. Oh, maybe it's edge based. Yeah, now it's working, but it's taking way too much for the purpose of the tutorial, so we'll just pause it and delete it. But in your final model, you can do, I mean, you can add chamfer, you can do whatever you want. There it is, managed to do it, but we don't need this. This is a tutorial to show the particle effect, so we'll just get rid of this. It's gonna work the same for our purpose, even too much probably. So this is the cage, and we can delete this duplicate because we're not gonna use it. We're gonna just keep this one as a source for future if I wanted to make changes, but right now what we're gonna focus on is the hexagons object, because I'm gonna, since Tyflow is parametric, I just remove the torus and pick the hexagons. And now the particles are already separated, and they're gonna fit on our cage perfectly. And yeah, now it's just a matter of, for example, 0.1 on the outer shell, and here we are. Remember that we have to turn on the shell option here, but remembering the original animation, the particles didn't go out based on the time test, but they were colliding with something. So let's turn off the flow for 1 second. Let's turn off the cage. Just keep the hexagons model outside, and let's make a geosphere, sort of like this. Then dummy, and we're gonna center the dummy on the donut, on the torus, and let's link the sphere on the torus, and then let's make it like 250 or so. Yeah. In a linear fashion, we're gonna animate this in, for example, yep, like this. Okay. Oops, sorry. Yeah, of course, the rotation needs to be, I needed to have auto key. Like this. Okay, we can hide the geosphere, make it non-renderable. You never know if you forget it, but we can hide it. And in our flow, what we can do here is just do a surface test. Let's pick the geosphere, and we're gonna choose the volume inside. So it's gonna be true if the particle is inside the volume. Okay, so if it's inside the volume, go out and push the hexagon out. Okay, see what's happening? It's already working, and instead of, we can delete this because we don't need it anymore. And what we can do here is, well, let me show you something. I'm gonna disable the surface test for now, and we're gonna use my favorite operator to debug the flow, the display data. What we want to see here is the transformation matrix axis. As you can see, they're all oriented they are all world oriented. What I want is to have them oriented based on the normals, on their normals. So what we can do here is simply add a rotation operator. And we're gonna add it before recording the transformation matrix. And we're gonna affect only the pivot. And we can do surface align. And let's pick the same surface we're using to generate the particles. So now, as you can see, the pivots are properly aligned. Okay, so we can hide the display data. And instead of the push, we're gonna just use, for example, speed. And it's gonna be along the particle Z. For example, a magnitude of 3 and with a variation of 15 is okay. So they start flying out and then they go back to their original position. It's not really the original position, but we're gonna see how in a second. Let's hide the hexagons. So as you can see, okay, so let's fix the position first, and we're gonna use just a stop operator. And now they go back exactly where they started. Also, I don't want the animation to start immediately. So we can just birth the objects. I don't know, maybe the surface test, instead of continuous, it can be done on event age and starting from 1, for example. Yep. Okay, it's working. And we can do something else. For example, we can add a force. And with a car noise 0.1. So let's see what happens. Yeah, there is a bit of we can improve this movement, for example, lowering the scale. And the time test, this could happen after 18 frames. for example. And we can add a spin as well. And a slow operator. Okay, some more force maybe. Yeah, now it's a bit more noisy. Okay. Okay, so instead of going straight to stopping stopping the force and going straight back, we can do this in a more elastic way. We can, for example, add a find target. And the target, instead of being an object, is going to be a custom TM, which is my TM. And let's see if the velocity is okay, and then we're going to check the distance to test through and go to this event where they're going to be sent to their original and final position. As you can see, the movement is a bit more smooth and wavy, and maybe we can lower this again, like 12, and find target, and we can add some for example, some easing when it gets near the surface, and then it can start the alignment towards the custom TM. So it's just stop spinning, and we can actually give it some more spin. Like, I don't know, 500. Okay. So the most of it is done. They go out and then they go back to their position. Let's add the splines, because in the original animation they had like a trail. So how do we do it? So we add the spline paths and create new. Okay, it's done. And then we're gonna copy and paste it. Okay. Yeah. And let's go to the Tyflow settings, and here you can see that you have like a maximum age, for example, of 10 frames. Let's see what happens. You can also set the maximum distance. Let's see what happens. Yeah, as you can see, the splines follow the trajectory, and it's just for based on age. We could base it also on distance as well, but age is okay. And let's see how they look. Yep. I always remove real time. I forgot this time, but I remove real time because I think it's better to simulate frame by frame. And I'd say that's it. As I said, it was quite simple. It's a really nice effect, but the flow itself is quite easy, and you can adjust it as you want. You can lower the speed of the collider, you can add more forces, and one thing I want to tell you. Let me disable the tie splines just for speed purpose. Also, let's not forget that we have the shell here, so as you can see, yeah, they have some thickness. One thing I did was adding a particle physics operator, so they didn't to give some particle intercollision, so the particles didn't go inside one. They didn't compenetrate, and let's see the collision radius if it's alright. Okay, based on shape radius, and so they're gonna push each other. Okay, they're not gonna compenetrate. But one thing you have to do here is, let's say I copy this and paste it instanced in here. And if you paste it here as well, they might not go back to the original position. So I didn't paste it here because I wanted them to go back exactly to the original position. But I had some problems because I forgot that particle physics can affect also events where it's not there. So what I did is just process only this event. If you disable this, you might have problems on the particles getting back to their original place. Let me hide the collision shape. This is not really perfect, but if I enable process only this event, they're gonna get back exactly at their original position. We could actually start the process of getting back to their original transformation metrics a bit earlier. So for example here, less than 4 with some variation. That's it. That's the tutorial, and I hope you enjoyed it. That's it. Until the next time, bye.